Hi friends, today we're going to be looking at how we add and subtract mixed numbers. And I want to remind you of all the things that we know so far. We know how to create models, we can decompose fractions using unit fractions, we can write expressions using unit fractions and other combinations, and we can add and subtract fractions with like denominators and in word problems. Today we're going to try doing the same thing but with mixed numbers. And I want to remind you that a mixed number is a whole number and a fraction together. So examples of a mixed number are 1 and 1/4, or 2 and 1/3, or 3 and 4/5, or 10 and a half. All of those are mixed numbers because we have a whole number and a fraction. So we're going to try adding together those mixed numbers. So let's try first. 2 1/4 plus 3 3/4. Now we can do this in two ways. The first way is just to underline our whole numbers and then add together our whole numbers. 2 plus 3 equals 5. Then I do the same with my fractions. 1/4 plus 3/4 is 4/4. Now I'm noticing that 5 and 4/4. I know 4/4 can be changed to something. And this might be a challenge, but I know 4/4 is equal to 1 whole. So I can add 5 plus 1 whole equals 6. And 6 would be my final answer. So that's one way, is to color code or separate your mixed numbers and fractions and add them as separate parts. Another way is to change the mixed numbers into improper fractions. And we do that by multiplying the denominator with the whole number and then adding the numerator. 4 times 2 is 8 plus 1 is 9/4. Plus, and now we do the same thing. 4 times 3 plus 3. 4 times 3 is 12 plus 3 is 15/4. And now I can add this together like it's a regular fraction. 9 plus 15. And I'm thinking in my mind, I know 10 plus 15 is 25, but 9 is 1 less. So 25 minus 1 is 24/4. And now I'm looking at this, and this is an improper fraction. Then we can change it back into a mixed number. And to do that, we ask ourselves, how many times can we count by 4 until we get 24? So I can count 4, 8, 12, 15, 18, 21, 24. So looking at that, and I know these are all 4/4. And now 4/4 is equal to 1 whole. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals 6. So we have the same answer for both, but we have two different strategies to answer. We're going to try this one more time with another example. Let's try this same work with another pair of fractions. Let's try 3 2/5 plus 2 2/5. So our first strategy is to color code our mixed numbers. Separate our mixed numbers. 3 plus 2 equals 5. And then do the same with our fractions. 2/5 plus 2/5 is 4/5. So very simple. Our answer is 5 4/5. We're doing things that you already know how to do. And one other strategy if you wanted to change it into improper fractions. So I'm going to rewrite our two fractions. 3 2/5 plus 2 2/5. 5 times 3 is 15, plus 2 is 17 over 5. We're turning them into improper fractions. Plus 5 times 2 is 10, plus 2 is 12/5. And I know my denominator is going to stay the same. Now 17 plus 12. So I know 17 plus 10 is 27, plus 2 is 29. And I can turn this into a mixed number by seeing and counting by multiples of 5. So 5, 10, 15, 20, 25, 30 would be my next 5. But that's too high. So I'm going to back up, and I'm going to count up from 25. 5, 10, 15, 20, 25, 26, 27, 28, 29. Okay? And all of these are out of 5. 5/5, 5/5, 5/5, 5/5. And we know all of those are equal to 1. And then I have 1, 2, 3, 4/5 left over. So my final answer, 1 plus 1 plus 1 plus 1 plus 1 is 5. And then I add my 4/5 and get 5 4/5. So we have two different strategies to attack the same type of problem. So you can choose which idea you prefer, and good luck.